Hi, Mr. Ray here. Hey, and this is the sixth video in our series. In this one, we start with the program, the My Block we had at the end of the third series, and we're going to continue and we're going to build another parallel program in this manner, somewhat like we did in the fifth video. Now, I have added a My Block here that's called gyro calibrate. And if I needed to run this, I could stick it up here somewhere, that, and that would run it right after I set up my wheels and stuff. This routine, as far as I can tell, works on all EV3 gyros. There is some difference between the early ones and the later ones, and this one is the only one I've found that will reliably stop the later gyros from drifting. And remember that drift means that the gyro thinks you're turning when you're sitting still. We'll talk about a menu program in a later video. You might include this then as one of the menu items that you could select. I've already pulled out and set up parts of the program that we're going to need to make this work for the next step. And what it's going to do is allow us to accelerate smoothly and slow down smoothly. Now, obviously, we could, if we don't want to bother with this stuff, we could pull in something like this. Now let's say I really wanted to go 5. I'll say 4, and I'll say 1, 0, at a speed of say 45. Now this would go 5, the total of these two would go 5 rotations, and at the end of 4 it would slow it down to 45. And I could string 2 or 3 more of these on if I wanted to do it more gradually. What I'm going to add will automatically smooth out acceleration and can smooth deceleration or slowing down. Let me shrink myself and you'll see a bunch of other pieces. Okay, so what we're going to do is when we enter this routine, we're going to see how fast the robot is going at that time. We will smoothly speed up to this new speed that is set, or slow down, whichever way it is. So the first thing we have to do is figure out how fast it's going. Now for that decision, what we're going to do is we're going to check, and first thing we do is we pulled in an if block, and now we say if the absolute value of the B speed, that's how fast the B motor is running, is greater than the absolute value of the C speed, then set the initial speed to B speed, else set the initial speed to C speed. So in other words, initial speed will contain the speed of the faster of the two motors when you enter this routine. So we need to do that calculation. After you've done that, we have to decide what size steps we want for this routine that's going to speed it up. In this case, I said I want to take the difference between speed, that is the speed that we want for the final speed, versus the speed when it entered this routine, and I divided it by 10, and I store that in a variable called delta speed. All right, so now I need to put this somewhere. There's any number of places I could put it. Let me move this thing out of the way. And let's see, I'd say somewhere like here would be just fine. All right, now we've got that going. And now then the question is, how do we make it go, do this accelerate, decelerate? Well, I have another routine here. Okay. And what I'm going to do is I've defined a new variable called g speed, and down in this routine, I will take speed out and I'll replace it with g speed. When I do this acceleration, deceleration, I have to have time to do it. I have to have enough rotation that it actually has time to do it. So I've put an if in here. I've said if the absolute value of the motor rotations, in other words, how far I'm telling it to go, either plus or minus, is greater than 0.5, I got a new block we haven't used before called broadcast accelerate. If it's less than that, I just immediately set G speed to speed. And then also in here, I want to put in to set the initial speed to G speed. I probably ought to do that the other way around, just in case. And I need to run this. as close to the front of this repeat as I can, because I don't want to broadcast this until it's close to starting. So I put this in right there. I'll leave the reset timer there for now. It might be a bad idea. So now I've broadcast accelerate. I've calculated a delta speed. So what is broadcast accelerate? Well, the operating system for the brick, and that's the control program, is kind of like the iOS in your iPhone or iPad. It's the underlying control program. That program has the capability of running more than one program at a time. Just like if you've got an iPhone or an Android phone, there can be things running in the background on your phone. Broadcast accelerate is going to tell another program stack to start running. And to start that stack, I need to say when I receive accelerate. And if I had more than one of these, I could name some other messages. So this one will be unique for accelerate. And let me get this out of the way. So now I want to change that. I've got a repeat loop here of 10. I divide it over here by 10. So in 10 steps, I want to change the speed of delta speed. And then each time I change it, I want to wait a little while. In my case, I'm going to say about 0.03. In other words, it will take 0.3 of a second for the speed to increase. You can mess with this and change it to other numbers, make it slower if you desire. What you got to be careful of is that it has time to completely run this loop while you're inside this repeat loop, or it may mess up whatever's going on after you run the my block. One of the dangers here is I could make this speed go to 0 before my repeat loop over here finishes running. I would do that probably by specifying the speed to be 0, or I might specify it to be too slow. So I added some protection, and what this block does, it says if the G speed coming out of this loop, now remember this loop's going to completely run before it drops down into this. It's going to test it. If the G speed is positive, it's going to say, is it less than 15? If so, set it to 15. Now you might get by with 5 here. I believe on my robot when I put 5 here that sometimes it's still stopped. There wasn't enough power for it to go. Now, if G speed is greater than 0, then do this. Else, in other words, it's equal to 0 or less than 0. I said if G speed is greater than minus 15, that means it is somewhere between 14.9999 and 0, then set it to minus 15. So in other words, I will not allow this routine to set the speed at speeds between minus 15 and plus 15. Now, setting out here, it's its own stack. When I broadcast this, this will run. Now you notice here we set G speed to the initial speed before we did the broadcast. So the robot down in here will start at the initial speed. Then as this loop runs, it will increase the speed according to this setup here. In my case, it will do it in 10 steps. If it's less than 0.5, I say, gee, there's not enough time to use this. I'll set the G speed directly to the speed up here. We did have to release the red speed dot here with G speed. Let's see, so we've got it all there. So I did mention that you can slow down. Now I could put a lot more programming in here, or I could write another one of these that's called decelerate, but then I would have to figure out when during this loop I should run it. Now, I can do that, but the methods that you use to do that slow the rate at which this loop will run, and so I chose not to do that. So if you want to decelerate, let me put this back to 5 for the moment. Suppose I was going 5 rotation. Now if I'm going 1 rotation, I don't need to go fast enough to even worry about this. But so I told it to go 90, and in this case it's not moving before it starts, and so that it will speed up from 0 to 90 in 10 steps in 0.3 of a second. But now let's suppose I wanted to slow down. Maybe I'm going to make I want to stop and I don't want to jerk it. I want to turn and I need to turn slowly because 90 is so fast it's hard to get a good turn. Let's suppose I wanted to slow down to 20 to do something else. Then I would say, oh, I'm going 5 rotations, so I want to go 4 rotations here and 1 rotation here. Now you could change this. This might slow down a little too much too soon. And then I would need to put my stop moving on here. And this thing will end the program. So there's the routine. I'll set the camera up and we'll see what it does. Okay, so now I have the camera set up. I also changed this first gyro to only go 3 blocks, otherwise the robot will go out of view. Now then, you'll notice that the robot actually slows down a little too soon. So let me run this. And okay, and watch it slow down at the end. So that was, if you needed a real smooth one, that might be all right. So I'm going to run it again, and this time I've changed the number of rotations to 3.4 and 0.6. So it's still going 4 rotations. It's just the slowdown will occur a little later. And let's try that. That was probably pretty good if you're wanting to get there as quick as you can. Now I'll show you one more thing so you can see how this thing stops normally. We're going to change this back to, say, 3.8 and 0.2. Still 4 rotations. Okay, now I'll bring the robot back. Now remember, it should not decelerate smoothly with the final gyro nav only going 0.2. It has to be more than 0.5 or it won't do it. So let's see what it does. You notice it just stopped pretty abruptly. That'll just about do everything we wanted in this video. Remember, you can go back if you don't want this really complex gyro nav. You can still use the one we did in the 3rd video. It's just you'll have to figure out how to slow the robot down if you don't want to jerk. And then obviously sometimes you want the jerk at the end to make something move. That is the end of this program, and if you want to see the remainder of the series, you can look in the Lego Classroom Navigation series on Raise Robotics. You can see all of the videos that I've completed for this thing. So be sure and subscribe, and I'll look forward to seeing you the next time.